Okay, Tom, it's off to you.
Well, welcome. I'm broadcasting today from the sumptuous offices of Lost Valley Visitor Center in beautiful Glacial Park. All my previous Tom talks were from home, but today we're in the offices of Glacial Park. And I welcome you today. This is a subject that's one of the most important sort of changes in my thinking over the last 35 years was what we're going to talk about today. Sort of reorienting the way I thought from looking at trees and looking at plants to looking at landscapes. I hope I can convey that to you today. It's a harder thing than just teaching about identifying objects, but we'll see how we do today. I welcome your questions at any point in the presentation, and we'll see how it goes.
My continents are killing me.
You're 4.5 billion years old. Get used to it.
I'll get used to it when they come up with a cure for plate tectonics.
Continents moving around again in your sleep?
You don't know what it's like. I haven't had a good night's sleep since Europe and Africa broke away from the Americas.
It was a terrible argument. I heard it way up here.
For real though, I think I might have a fever.
COVID. I'm telling you it's COVID. What did I tell you about getting too close to Venus? You gotta keep your planetary distance. 30 million miles minimum, unless you're both masked.
But I think it might be worse than COVID. I think it's climate change.
Not again. You know you've been worrying about that since the first Earth Day in 1970.
It's for real this time. It's October and December. Tornadoes, hurricanes, ice caps melting, wildfires. It never stops.
I know it sounds bad, but you weathered asteroid impacts that blew a hole in your crust 90 miles wide. It was dark for ages, so this really can't be that bad. There's something else bothering you. What's up?
It's the people.
But I thought you liked people.
I do. I like the feel of their feet dancing on my soil, the song of their voices, their poetry. That Homer guy was the best.
You're dating yourself again, sis. Can we talk about something that's maybe happened in the last millennium?
I just don't think they know me anymore. They used to think of me as their mother. Now I'm just a place to park their cars.
Yep, that's my sister. The big round parking garage.
It's not funny.
Look, I think you're making a mountain out of a molehill. Well, maybe a large molehill. Why, just the other day, I saw these people out looking at rocks and measuring trees, drawing maps. I mean, I don't get that kind of treatment. They came up here half a dozen times, took off and left a lot of metal garbage behind. What am I supposed to do with all that stuff? You've at least got an atmosphere. A little too sensitive, perhaps, but people love you.
You really think so?
Of course. I'm your little brother, so maybe I'm biased, but yeah, you're okay.
I think my continents are feeling a little better.
Take 2 aspirin and get some sleep. And give my best to Homer when you see him next.
Well, after that splendid introduction, I'll actually come back to a couple of those themes, the Earth and the Moon we're talking about today. How geological forces shape the living world. I hope this is more than a review of geology for you, but it's really about seeing something that maybe you haven't really seen before. You think you've seen a forest, but maybe you've been in a forest, but have you actually seen it? I think most people see the trees. Or they see the plants growing on the ground. I know I did. That was kind of where I was about the middle of the 1980s. And when I was first had to struggle with seeing the forest, it was actually quite difficult. So let's talk about the word ecosystem. This is one that's thrown around by scientists. It's now pretty loosely thrown around in sort of popular vocabulary. And this, do a definition just like this, you'll get in any dictionary or go online and look for a definition of biological community of interacting organisms in their physical environment. And that's what we call an abstract functional model. It means that it's really about how things work and not what something is in a sense. In a sense, I hope that becomes clear here in a minute. So an abstract functional model is something like this. I mean, this isn't any particular forest over here. It's a forest that burns up and then grows back into a forest again. This isn't a particular place. It's a model of how energy moves through a system. Likewise, this is another model of how energy moves through a system. And these are important in ways of understanding change and in ecosystems. But most importantly, ecosystems in this way don't have any boundaries in time and space. So I can't point to one like I can point to a tree, or I could point to you as an individual, or any individual, your car, your tree, your house. There's an individuality that's lacking in those first definitions. So we want to think about ecosystems not as just functional models, but as actual things in the world, as places. And here's a definition. Ecosystem is a land individual. So that word individual pops up again as an actual thing I could point to. It's the geologic form, the soil that forms at its surface, the biotic community, and that portion of the atmosphere intimately associated with these things. So this ecosystem is an actual thing in the world that I could walk into and out of. And therefore, it has boundaries in time and space, and it has a surrounding. So we'll call that surrounding the larger landscape. So, and this way of, well, here's an example of a land individual, Exner Marsh. I like this because Exner Marsh is in such a foreign surrounding. It's very indicative of the plight of all natural areas today, these land individuals, these pieces of landscape that are now in a foreign landscape. And this is an important understanding because ecosystems are maintained and changed by their interaction with our larger landscape. So this viewpoint, this looking at the land individual, at the ecosystems that are a part of it, is important to understanding how things change in the modern world. They're embedded in a foreign landscape, and so there are always influences crossing the boundary, coming into and changing ecosystems. This is really the standpoint, or to me, the sort of basis for understanding why we need to do ecological restoration today. Individuals have histories like Glacial Park, like any of our natural areas today. We can look back in the history, look at 1939 aerial photographs, we can look at public land survey notes, we can look at geologic history, we can infer various other things from history, but real things like you or I or your car or your house all have histories that we can look at. Abstract functional models don't have a history, they're simply about processes. And again, parts are understood in terms of their function in the whole. So this is a thing, I hope you at least get a glimmer of it today. I mean, I love trees. One of the tree Tom Talks we did last year, I talked about the episode of identifying my first tree, camping trip with my father in the summer of 1980, and how I still remember that moment of identifying my first tree with my Audubon guide to trees of the eastern US, and how important that was. And for years, that was just a total focus. I just love trees. I just went from one tree to the next, looking at them, looking them up, and just having enormous pleasure in identifying them and figuring them out and looking at them and seeing what they were made of. But it was a few years after that when I started to put them into a context, and I really got an understanding of trees I never could have gotten just by looking at the tree itself. I then put it into a historical context, into a landscape context, and the tree began to mean much, much more to me. I hope you get at least some glimmer of that today. So we're going to look at some examples of these ecosystems, these real ecosystems out there in our parks and natural areas today. And to do that, we're going to organize those in a way, just organize the presentation by these ecosystem factors. I always go back to Hans Jenny's classic work. I think I mentioned this in the soil webinar, Factors of Soil Formation. The first half of the book is one of those lucid discussions of soil and its formation ever written. And he talks about these independent factors. And soil, in fact, is an ecosystem. It's living, it's non-living, it develops over time. We're going to take those factors, and we're not going to talk directly about organisms today, but indirectly, and we're going to look at the physical landscape, definitely geological in the broadest sense of geology, because geology is going on today in rivers and streams and wind blowing sediments around. We're going to look at geology and how that affects this development of the living world. Relief or the surface shape of land influences water and fire movement, and in fact, also influences microclimates, which we'll talk about today. And the first thing we're going to do, in fact, is to look at microclimates. And the reason I do this is because it really addresses the issue of climate change and conservation in general, and ecological restoration in specific. Climate change, I've said for years now, is one of the two biggest problems that faces conservation and ecological restoration in the next century. It's one that we won't be able to turn away from, but we'll have to look at directly. It will begin to affect the way we do things, how we do and what we do. And this bar chart comes from a study I did with part of the phenology project a few years ago. I think this is 2019 data. I put temperature sensors around Glacial Park in a variety of landscape positions and looked at the average temperature over a whole month. So this isn't, picking out, cherry picking one time of day where it was different, but rather averaging temperatures every 4 hours for an entire month. And you can see that there's a substantial amount of variation between these different sites, 4.4 degrees. Now in phenological terms, that's, and the reason I use March temperatures is because that seems to be most closely correlated with the blooming of our spring ephemeral plants. If we look at, I don't want to really go into the whole phenology study, but the 4.4, looking at the relationship between temperature and blooming, we find out every degree of temperature changes the bloom date by about 1.7 degrees. So that 4.4 degree change in temperature equates to a little more than a week in bloom dates. And if we look at average temperatures over the latitudes, say from Madison, Wisconsin down to central Illinois, that equates to about 0.03 degrees per mile or 147 miles. So within Glacial Park, there's just a few miles. We've got really about 147 miles worth of variation in temperatures. This could be very, very important as the world gets warmer and plants need to move around and find cooler places to live. This microclimate variation could become critical. Let's look, for instance, at the warmest place in Glacial Park, which is the very steep south-facing slope above the Kettle Marsh. There's Kettle Marsh. You know how to read a topographic map. These lines close together means the slope is steep and it's facing southward. There you are on this south-facing slope. And now let's compare that to Nipperson Valley. So the south-facing slope was at around 37.5 degrees, and Nipperson Valley is around 34.6 degrees. There it is, maybe a half mile away, out in the middle of a big flat valley. It's about 2.15 degrees cooler. That's about 3.7 degrees, 3.7 days difference, or the equivalent of about 72 miles. So just within a half mile of one another, that kind of microclimate variation. All this goes back to the physical shape of the landscape. The valley was created by the meltwaters of the last glaciation, as the that steep gravel hill on which our previous slide was focused is an ice contact slope, meaning a pile of gravel that was piled up against a massive block of ice. That's where Kettle Marsh sits today. So geology really accounts for the differences between these two sites and for their distinctly different microclimates. Let's look on an even smaller scale at an individual Kettle Basin. Many of you know where the old Glacial Park field station was. It's up here just above the level of this top of this photograph. And this is the deep hole in the ground just south of it. The deep Kettle Basin is close. Here are our topographic lines are very close together, meaning a very steep slope on the west side of the Kettle Basin, equally steep slope on the east side of the Kettle Basin, and here's the bottom of the Kettle Basin. Now let's look at the differences in temperature. Considerable. We're going from 34, maybe 34.1 degrees, 34.2 degrees, up to about 36.4. So you're getting about 1.9 degrees difference, about 3.2 degrees in bloom date, and the equivalent about 63 miles of latitude. And that's over 150 feet of difference. This is the striking effect that these local microclimates can have, all a function of the geological landscape. And this could end up being a very important feature of landscapes as our general climate warms. And some of our plants may need to migrate locally to cooler places, as opposed to having to migrate 63 miles north out of Glacial Park. So now let's look at water movement, another feature really of the surface shape of land, a surface shape of those geologic forms. Now I asked a simple question, in an acid wetland like Glacial Park, sits in a very strongly alkaline landscape. All the gravel hills around it, such as you see in this photograph, are made of dolomite or limestone gravel. Water filtering through that is strongly charged with mineral nutrients and strongly alkaline in pH. How do you end up producing an acid bog? So as we change that focus, we're looking up from the trail, up into the woods, Baroque woodland growing on that acid or on that alkaline gravelly ridge, out into a bog with a dense growth of leatherleaf vegetation, a plant that loves acid soils. And the soils in that bog are sphagnum, really sphagnum in the roots and leaves of leatherleaf, a peat soil, very acid in pH. So how do you get that in a landscape that's surrounded by strongly alkaline gravels? And what we're going to look at, I'm going to do a cross section through the bog and marsh and out to Lost Valley Marsh on the east side, and just look at that topography. Now this looks a little weird, but that's about a 40-fold vertical exaggeration. This is just to help you see the elevation differences, and notice that the bog is slightly higher than all the other wetlands. The water is coming out along the side of the hill here above Nipperson Creek. It comes out again along the side of the hill at the edges of Lost Valley Marsh. The Kettle Marsh is about 1.5 feet lower than the bog, which means that as water goes into the bog, it moves through the bog mat and outward. So the bog is fed by acid, nutrient poor rainwater, and water moves through and out of it, whereas the Kettle Marsh is being fed by water coming from the bog through the soil material into the bog soil, and it's being fed equally by water coming through the steep hill on the north side. We looked at the same graph when we were looking at microclimates, into the bog soil. So it's being fed by a lot of groundwater and rainwater together, whereas the bog is really being fed only by rainwater. So that's how we develop that really strongly acid ecosystem in an alkaline landscape, and why the bog and the marsh are two different kinds of ecosystems relatively close to one another in Kettle basins that look more or less the same, slightly different shape, but formed at the same time, yet they form strikingly different wetlands by virtue of the just slight difference in elevation and how water moves through them. Let's look at another ecosystem that's really a function of how water moves through the landscape. This is Nipperson Creek. Lost Valley Visitor Center is just out of the photograph on the bottom. This is the North Region shop for our land or sites and fleets crews. And this is the big valley of Nipperson Creek, one of my favorite places in the park. Favorite because it takes a while to walk out there. When you're out there, it's one of the most lonely feelings in Glacial Park, and it's nice to feel lonesome sometimes today in a crowded world. So let's look at this spot and look at these funny lines that run through here. out in the middle of this valley. What are these strange lines and arcing shapes? And what they are old courses of Nipperson Creek, formed long before European settlement. And to look at one of those, we're going to do another cross section through the landscape. It crosses the present creek and the former channel of Nipperson Creek, probably many centuries before European settlement. The first thing I want you to notice is just the difference in size, the relatively large size of the valley in which Nipperson Creek flows today, and the tiny little valley that Nipperson Creek flowed in before. Now, the pink line is the actual river sediments. The space in between that and the dark line are just the sediments that have accumulated in that basin since the stream stopped flowing through it. So the Rit was a very different stream back then. It flowed through a very different landscape. It held its water much better, much more longer periods of time, released it more slowly. And so the stream never carried nearly as much water as it does today at flood stage. And so it was a very different stream, but still far enough below the landscape that it creates a wet swale. And when we look at that landscape today, we see this very distinctive sedge meadow growing in the old channel of Nipperson Creek, very different from the vegetation around it, which is dominated, at least until our most recent restoration, mostly by the exotic reed canary grass, now by goldenrods and a lot of other prairie plants. But the stream itself, just slightly lower, really a function of recent sort of geomorphology and the flow of Nipperson Creek, creates a very distinctive environment for distinctive vegetation. Here's another ecosystem we associate with moving water. Here's a bottomland forest. This one really along the boundaries of the Des Plaines River in Libertyville, where I live. What I wanted to say is that this, those of you who know much about sort of pre-European settlement ecology around here, know that bottomland forests really are mostly a function of the modern world. This was probably an open meadow 300 years ago, and it's due to sedimentation and erosion. It's been colonized by plants like silver maple and cottonwood and hackberry, green ash, really form these bottomland forests today. But again, always in association with rivers in stream, with erosion and sedimentation. Here's the Des Plaines River. We can see, looking back in 1939, it was even an open meadow then, other than just a little trees along the edge, and then another fringe of trees here we'll look at in just a second. But now that bottomland forest is fully colonized the basin. Here's a cross section showing where the Des Plaines River, and they're very gradually coming out of that river bottom into the terraces, the bottomland forest, and then the Baroque Savannah that forms and is really more historical vegetation along the edges in a slightly higher terrace location. And we'll see that one right here. So we're looking right at a Baroque right now, and then panning across and eastward, there's another bur oak. They're just scattered right along the edge of this river. Now we're looking down into the bottomland forest eastward toward the Des Plaines River. So very subtle change in elevations, probably just a foot or two, and yet that was important to the establishment of those bur oaks in years past. And the reason why that was formerly an open meadow, probably wet prairie sedge meadow, and now a bottomland forest. Let's look at another situation. This one is just right next to Lost Valley Visitor Center. I can't throw a rock very far anymore, but where I'm sitting in my offices, if I could throw a rock about 150 yards, I could hit this spot. This is the trail that comes from Lost Valley Visitor Center. As you're walking south, you get an opportunity to turn right and go into the woods. And right as the trail turns left, you see a kettle basin, very shallow kettle basin off to the left. That would probably, you've walked past it many times if you're familiar with Glacial Park, and you've never noticed that it's bur oaks growing down in the bottom of that basin, and it's white oaks as you look to either side as you go up the slope. So here is down in that Kettle Basin, you see that little bit more moisture, you get much more organic matter in the soil, a deeper, darker soil. Looking up to the Baroques in the immediate vicinity of that site. That was the Baroque Savannah at the bottom of that swale. Now let's look just up out of the swale, maybe 50 feet away at these well to moderately well-drained soils along the edges that are white oak. Notice the soil is a much shallower organic accumulation at the surface and really dominated by white oaks. These are separated by maybe 50 feet, so a very subtle landscape feature. Many of you have walked past 50 times, and yet have you ever stopped and noticed that very subtle landscape feature and how the movement of water on this, what's a dense clayey soil right here, the water moves through that surface soil layer, and even shallow depressions such as the one we're thinking about right now, pond up that water during wet times of year and lead to a strikingly different woodland composition. Another site in Lake County, this is a old school forest preserve east of where I live in Libertyville. And this is on the lake border moraine, another glacial moraine made up of very dense clay material, hence water really only penetrates the upper 30, 40 inches of soil and then begins to move laterally. So every little depression ponds water in the springtime. And you see a number of them I've circled within Old School Forest Preserve. Let's look at one of those. And right along the fringe, we find a somewhat poorly drained soil and bur oaks growing. And as we pan out of that slight depression upslope, you see all white oaks, basically all white oaks and maybe a few red oaks scattered as we look up. So again, a subtle landscape feature with a major impact on the vegetation. It's a little diagram. I mean, this makes it look like a big hill, but it's only 5 feet of elevation difference between there and there. The water coming to the surface in that ephemeral pond and shallow, just under the shallow surface as you move up the hill. Very characteristic of a glacial moraine, where the soil is made of very dense clay material. It has a characteristically perched water table. So at wet times of year, the water is perched just under the surface, and every subtle change in elevation makes a big difference in soil drainage and in the sorts of trees and wildflowers that will grow there. We'll look at time as a factor in ecosystem formation. And time is a special kind of factor because we could think of as relief as actually affecting water movement, but time is a dimension like width and breadth and depth, and things happen in time. So let's, do we want to take a break now, Jackie? I guess we're about 10:30. We could let's take a 5-minute break now. Okay.
If
So
you need
I
to
will
grab a beverage or anything, or use the restroom, you can head out, or we'll take questions if you have any.
and you can come back to the beautiful sound of water lapping the shores of Lake Michigan. So we'll reconvene in about 5 minutes.
Hey, Tom,
Okay, ready?
say we had a question. Pause the
Okay.
video. They had a question to tell us about the beach rocks.
The what?
Said, tell us about those beach rocks.
Oh, beach rocks. Well, this is a nice picture to talk about the beach rocks. This is you can, I've worked along the shores of Lake Michigan and the Great Lakes on a couple of occasions, and you can recognize a beach, even a beach that's 12,000 years old and the lake is a mile away. You can recognize the beach by the rocks. I mean, you can't tell the shape of the rocks in this photograph because you just get a two-dimensional image, but the rocks more often than not tend to be flattened, called shingle, beach shingle. And if you go on the active beach of Lake Michigan and dig down with your hands, you'll see there are layers where the water is more aggressively pounding the beach, and you get the gravel deposition, then it slows down, you get sand deposition, and it's strong again, and you get more gravel deposition. You get these layers of beach shingle. And if you look at that and then start poking around in other places, some of which I'll show you just in the next few minutes, you can find the beach shingle. Sometimes it's been isolated now from the present lakeshore for thousands of years. So that's why you get all these flattened rocks together, is just the action of the waves sliding the rocks back and forth on the sand, flattening them. Even pieces of basalt that have no sort of internal structure that would lead them to be flattened will end up being flattened by being played with by the waves for a long period of time. I can't go to the beach without picking up rocks. I have to make a deal with myself not to. I always say I'm only going to pick up one rock, and then one becomes two, and I try to hold myself back to about a half a dozen, but it's hard. If you look at my office, there are rocks all over the place. Is that good?
Yeah, and we're at about 5 minutes, so hopefully everybody's back and we can keep going.
Okay. So let's look at Illinois Beach State Park. It's a neat place to look at time and the development of ecosystems. Some of the classic work on what came to be called ecological succession or plant succession was done over 100 years ago along beaches. Just because they're very inviting places, they seem to form over time. And certainly as you walk from the beach backward for a mile, things change. And so there's that correlation of change in time. Very tempting to look at that correlation. The ridges that you saw in that last photograph are really formed as the lake. Let's go back for a second. This over here, where the cursor is, would have been the beachfront 6,000 years ago. It was called the Nipperson level of the Great Lakes or of Lake Michigan. So this all would have been covered in water. And then obviously the water is here at the present shoreline today. And as the lake recedes, the sandbars are isolated onshore, and the dunes then deposit more sand on top of the sandbars and accentuate the sandbars, and that's what leads to that sort of parallel series of dune and the dune and swale ecosystems in many areas along Lake Michigan. But time isn't linear in this case. At least it's not linear in space, because you can see the beach ridges arcing like this. So what would seem to be fairly recent ridges over here are actually arcing back almost all the way to the old 6,000-year-old beach. And in all likelihood, this whole area has been formed in fairly recent times. And if we look at this diagram, you can see that this is the 6,000-year-old beach right here. We'll look at that more up close and personal here in just a second. And you can see that within about 1,000 feet, the level of the land goes down practically to the level of Lake Michigan today, just a couple of feet higher. And so all the change from year to year is compressed in probably 1,000 or maybe just a little more than 1,000 years, and all the rest of it is compressed over here. So these ecosystems particularly you get over this end, are much older than all of the ones over here. So now let's just keep that in mind, and we'll start to look at some of these ecosystems, starting with the primary dune, called primary just because it's the first one that forms along the edge of the lake. We'll move back one step to what's called the secondary dune, and then to the prairie on these beach ridges, and then to the black oak forest, etc., back to that 6,000-year-old beach. Here we are in the primary marram grass dune, and you can see that there's very little organic matter in the soil. In fact, it looks just like a pile of sand, and it's colonized by this one species of grass that is a super specialist in colonizing unstable sands right along the shores of Lake Michigan, all through the Great Lakes. Those sand colonizing species of grass are all over the world, not marram grass, although there is a species very closely related to marram grass, that's the dune colonizer. In Great Britain, if you go to the Gulf Coast, there are sea oats, a species of the genus Uniola. That's the beach, the sand colonizing grass there. So let's take one step back and look at the secondary dune. And here we are in an area. Again, we have some exposed sand, a little bit of sand moving around, but much more stable. And it's now covered by creeping juniper. You can see the marram grass just on the horizon of that primary dune. So we're literally only 50 feet away in a very different looking place, isolated from at least some of that sand movement of the primary dunes. Take one more step back into the prairie, and we see some soil development here. We probably got a soil that's been stable for at least some centuries. Still a lot of sand you can see at the surface, so the sand continues to move here and there. It's not nutrient rich enough to support a real continuous dense sward of vegetation. And one of the peculiar things about this prairie, because you can see this exposed sand, when fire moves through here, it leaves patches unburned. And so we see plants growing in this prairie that you don't see in most prairie, like prickly pear cacti, bearberry, which is an evergreen plant, really most frequently encountered in bogs up north, both very fire sensitive species, together with the creeping juniper and common juniper, none of which we think of as prairie plants, but they're able to grow in this prairie because it has all these sandy patches that isolate, at least patches in here that don't burn. We'll go back again now and look at the black oak woods a little bit further back, so at least slightly older, more stable. You see less exposed sand here, and a vegetation that has a more open savanna look to it. You know, probably most of our savannas in Glacial Park, with the exception of the species of oak trees, would have looked much more like this 200 or 300 years ago than they do look like closed woodlands today. If you look at the public land survey notes, this looks more like the landscape those surveyors were seeing than what we see today. One more step back, we're going to cross this big area of Dead River wetlands to the Baroque Savannah. Now, the Baroque Savannas aren't something we normally associate with dunes, but if you look closely, this is outside of the really intensively managed parts of Illinois Beach State Park. But here you find a nice Baroque savanna. It's full of invasive trees. Here it's lost its original ground floor. But when we look, let's start that again. Look at that soil. Look at that soil development. So what that's telling you is that there was once, in the not too distant past, a very dense grassy vegetation that covered this area that filled it up with that organic matter. Notice also that the sediment down here, at least in this little patch, still looks very much like beach sand. Doesn't look very strongly oxidized. So even this site, now probably 3/4 of a mile from the lake, doesn't look all that old. The sand will eventually turn orange. We'll see that on our next site with increasing age. So now we're going to go all the way back to that 6,000-year-old beach. And notice this sand here, this is a white oak, red oak savanna, again, outside of the really intensively managed parts of our Illinois Beach State Park. But that red sand tells you this is a much older site. That's a soil forming process that happens more slowly. You have to weather primary minerals, release iron into the soil solution, and then that rusts to create that orange color. That takes much longer than the buildup of organic matter. So this is a much older site. This is right at the edge where the lake would have been lapping against the shoreline, and you see it while you're looking. Now you're looking at that, what's left of that wave-cut cliff. The waters of Lake Michigan have been pounding you. This would have been the primary dune or the primary beach 6,000 years ago. Now isolated more than a mile from the shoreline, a white oak and red oak woodland. So we see as we go back from the lakeshore, a lot of change, and yes, the change has happened in time, but we can take time apart in a sense and look at the actual processes that were causing those changes. And one of them is that the sand is extremely mobile and moving around constantly in the primary dune. All throughout these first four, we see bare sand patches here and there. They're dunes that are probable dunes and swales that have been formed over the last maybe 1,000 years, maybe a little bit more than that. Some, obviously the black oak savanna, just a little bit more stable. But as we move to the other side of the wetland complex to these, we see much more soil development, in particular here along the lakeshore, or excuse me, along the old lakeshore 6,000 years ago. Let's look at, this is the sand erosion and deposition, very unstable, going to very stable here on the left hand or part of this area far from the lake. Likewise, with soil development is very high over here, relatively less in this much younger area of the beach. So it's the development of the soil, it's the movement of the sand that's really affecting ecosystem development, and that's related to time, but it's not time itself that's causing the change, it's these other processes. Let's look at fire influence, and this is admittedly a bit hypothetical. I don't have a time machine. I can't go back and look at how fire moved through this landscape before, but anywhere where you have this kind of topographic diversity, large wetlands, fire would not have moved uniformly across this landscape, but would have been affected by the steep slopes over here that would have impeded the movement of fire, at least fire coming off of the upland. Likewise, with the dunes over here and the exposed sand at the dunes would have led to the less fire influence. And so we have a landscape that's heterogeneous in fire influence, a landscape that's heterogeneous in sand movement, a landscape that's heterogeneous in soil formation, and that's what's producing this tremendous variety of vegetation, beautiful variety of vegetation in Illinois Beach State Park, starting along the lakeshore and going back all the way to that 6,000-year-old beach. So time is an important factor, but look at what's happening within time. That's the really interesting part here. And start basically anywhere. Fire is influencing vegetative growth. Vegetative growth influences sand movement. It influences soil formation and influences fire, because the more vegetation there is, the more fire there is, or the more fuel there is for the vegetation to burn in. As you change sand movement, it affects soil formation, because where you're moving the sand around, it's constantly replenishing fresh sand at the surface of soil that needs to be incorporated into soil formation again. Where the sand is moving, it's affecting the movement of fire. So all these factors are interacting with one another, plus many other factors that are really what's happening in time. That's the interesting part of looking at at Illinois Beach State Park and the variety of vegetation. Parent material. Now we're looking at the actual geologic material that was deposited by, in most cases, the glacier or by rivers and streams. Let's start with here in Glacial Park. This is the same Kettle Basin we looked at with microclimates just south of the old Glacial Park field station. There's the old field station, and here's that Kettle Basin. There's the bottom of the basin. Here's the ridge that if you walk through that parking lot, you can walk on a little trail back to the main walking trail. The Rodman Casco soil series is really the exposed gravels. I mean, if there was a little bit more detail, that would show this much more finely textured soil at the bottom. Here is standing on that ridge, just south of the field station. We're going to pan kind of through the gravel, the Baroque gravels. There's the field station in the background, the mustard yellow buildings. So the Baroque's growing on that alkaline gravelly ridge. Up here, that excessively well-drained soil developed in alkaline gravels. Now we're going to look down at the white oaks growing toward the bottom of the Kettle in a silt loam soil that is often at the bottom of these Kettle basins. Small kettles, large kettles throughout Glacial Park will have this silt loam soil at the bottom. And you see all white oaks, same landform, really, a Kettle Basin, but in this area with a veneer of silt loam soil on top of the gravels, and then hosting a very different overstory in the sense of white oaks, but also it's an acid soil as opposed to an alkaline soil, so potentially a very different ground vegetation also. Again, geologic forms really shaping the environment in which these biotic communities develop.
Hey, Tom.
Yep.
Just for reference, what is an ice contact ridge?
Okay, good. I meant to say that. Ice contact. Ice contact means that as the glacier is melting, in certain situations, fragments of ice break off, and you have just big hunks of ice, and I mean big, like sometimes the size of city blocks, sometimes maybe only the size of your house or smaller. But these fragments of ice break off. The water from melting glacier are swirling around, they're depositing sands and gravels in contact with the ice. So the sands and gravels are deposited in contact with the ice. And then as the ice melts, it leaves holes. I'm glad you asked that question. I really meant to talk about that when I went past that slide. So the Kettle Marsh in Glacial Park is an ice contact feature. It's a giant kettle hole, and the steep slope immediately north of it is an ice contact slope, meaning it was gravels deposited in contact with the ice melts and the gravels slump back to the steep ridge you see today. Likewise, this cane feature here is the positive, the hill feature in an ice contact landscape. The wetland here is a Kettle Basin. This is gravels deposited in contact with the ice that have slumped into this hill form you see today. This is Larson Prairie in the southeast part of the county, a beautiful, beautiful little prairie that's only about a half a mile east of what is the big, give me some help, Jackie. It's the big.
Like in the hills?
Like in the hills, Finn, yes. There's something about being on Zoom that makes my faulty memory even faultier. Like in the hills, Finn, beautiful, big, beautiful naturally. This is about a half a mile east, right along the prairie trail. You see the hill form of on which Larson Prairie sits. There's the prairie trail. Here's the Marsh, the Kettle on that side. This is the cane. So there was an ice block over here. The gravels were deposited in contact with the ice. They slumped to this hill form, and later they cut a path for the prairie trail coming through it in that beautiful. And this is the prairie you get here with of side oats, grama, and the prairie. We have little blue stem in the both prairie clovers. Beautiful gravel hill prairie. Relatively small, but a beautiful gravel hill prairie at Larson Prairie. Let's look at another ice contact feature, the Baroque Savannah Ridge at Stickney Run. There's the Marsh. Here is Barreville Road. You drive south and Barreville Road from Richmond, Illinois, and go right past the shop for the land facilities people. It's just outside of the picture here on the south side, and this is a gravel ridge. And there is, let's just take a look here. And this is a restored prairie, not nearly as diverse as the prairie at Larson, looking out into the Kettle Basin. Again, these are geologic forms. There's a Kettle, you're standing on the cane, formerly inhabited by a very diverse marsh community and a very diverse oak savanna community. Now we're rebuilding that community today. And there's just a cross-section diagram showing Barreville Road, the Kettle Basin, and the excessively grained gravels of the Baroque Savannah here in Stickney Run. Oops. Now we're going to look at fire influence. And fire influence is really controlled by topography, surface features like water bodies and the surface shape of land that influences how wind blows across the landscape and therefore how fire moves through a landscape. So geologic influence lots of other factors like fire. And first, we're going to go to Pleasant Valley, which is here south of Woodstock and just south of Route 176. And I'm going to zoom in to this spot over here. And this is the Glacial Moraine here. This is the positive hills along the edge of the fairly extensive valley. And these are 6 miles square. So this is, while it doesn't look like a very long distance, this is several miles across the valley of the Kishwaukee River here. So we're going to be looking right along the edge of that valley and looking at this Baroque Savannah here on what for Illinois stands as a fairly steep slope looking out across the Kishwaukee Valley. Now, the question is, why is this a Baroque Savannah here? It's growing on a silty clay loam soil of a glacial moraine, soils that will, under many conditions, host white oak and red oak, white oak communities. Why is it Baroque here? And the answer is that this is a steep wave-cut cliff right along the edge of that huge valley that was once full of glacial meltwater, and the waves coming off of that large lake were pounding against the glacial moraine, cutting that steep slope. And the ecosystems that develop there are then subject to the fires that are moving across this extensive marsh, wet prairie, sedge meadow valley, burning up that slope. And so this is a place of extreme fire influence, and therefore Baroques and their extreme fire tolerance dominate that area to the exclusion of white oaks, which we'll see just up on top of the moraine in a very similar soil on a similar landform, but without the steep slope and without the degree of fire influence. You change from dominantly Baroque to dominantly white oak. Again, some change in little change in soil development here, but not nearly as much as simply the change in fire influence, going from that steep scarp at the edge of that huge prairie valley to this rolling morainal upland, only probably a half mile away. And now we're going to go out to Marengo Ridge again to look at fire influence and topography. This is a fairly steeply rolling landscape of the Marengo Moraine, north of Marengo, Illinois. Here in the rolling hills of Marengo Ridge, we have dominantly white oak woodland. It's well-drained soil. pretty typical of glacial moraines all across the Chicago area, where there was a rolling morainal upland and reasonably good soil drainage. White oaks dominated almost to the exclusion of every other tree species. And here, this is where we were. Again, a lot of vertical exaggeration, but this is the top of the Marengo moraine here. And this is where we were on that silty clay loam soil developed in the Marengo moraine within what was a fairly large woodland complex. Now let's go all the way to, now we were over here on the ridge before, now we're going to go all the way to the edge of the valley on the other side. Again, this valley is several miles wide. Here where I zoom up a little bit closer to see this valley, which is probably well over 2 miles wide. So there's, over 6,000 feet. Rush Creek runs right along the edge of that former extensive outwash plain. See, when the glacier is sitting on this Marengo moraine, all the meltwater moves over here and then flows southward through that valley, creating this extensive outwash plain. Again, the theme of this presentation, these geologic events create a landscape in which you find all the beautiful diversity of vegetation in McHenry County is keyed into that glacial landscape and really follows those changes in topography, parent material, and fire influence. So we don't have a natural area here. I really stopped just along the edge of the road just to look at just the flatness of this vast outwash plain that was once covered by prairie. Just try to visualize that. Try to imagine you're looking across miles of prairie. I try to do that sometimes myself because it seems so far away. I just try to imagine what looking across the landscape of miles of prairie would have been like. And now you're looking at the Marengo Ridge. That little dark line is the ridge that seems so obvious in that cross-sectional diagram I showed you before. So pause. What I want to try to do in these last few minutes is to put some of these pieces together. Fire influence, parent material, landforms, soil development, all of those, try to put them together into a package that allows us to look at landscapes and understand how they're put together. Understanding a land individual. I mean, this is a key. This is what this approach has done for me in the last 35 years. It's allowed me to see the land as an individual place and understand how it's put together. So here's a land individual. This is in Glacial Park, just south of the bog, Kettle Marsh. This is the old field station. In fact, this is the bottom of the Kettle Basin we were looking at just a few minutes ago. And the slightly finer textured soils at the bottom. This is the gravelly ridge. And so here we can look at all those factors put together and we can map out these ecosystems. Remember, this is ecosystems. Here's a landform. This is a gravelly ridge, an ice contact ridge of gravel covered in bur oaks. There is an ecosystem I can look at, I can point to, I can see its boundaries. I can then try to understand how it communicated with its surroundings, how fires moved through it, how seeds moved across those boundaries, what maintained it as a Baroque Savannah. This is the little basin that's now Turtle Marsh we restored now 10 years ago. Here is the sort of fine textured basin that was formerly covered in white oak, red oak, and some Baroque savannas. So distinctively different ecosystems from these gravel ridges. We can back up and we can look at glacial, we can look from a larger scale, take the same approach, looking at glacial landforms and the complex local ecosystems that form within each one of these major divisions. So here is the whole ice contact system in which much of the interior of Glacial Park is is formed. So here are those, all our marsh and bog, much of what I've been showing you today. This is the Nipperson Valley. This are the morainal ridges on both sides that frame both sides of the interior of Glacial Park. Each one of these has a complex of ecosystems distinct from the others. This is a way of looking at that large landscape and seeing the distinctive differences that these major glacial landforms, how they create very different sets of ecosystems in this area. We can back up even further and look at the entire county. This is a map developed by Mary Zander, graduate student of mine in my last years at Northeastern Illinois University, almost 20 years ago now. Again, now we're looking at landforms on an even larger scale, but again, looking at the ecological, the complex of ecological systems that form within each one of those major landforms and how they differ from one another. There's the Marengo Ridge we were on before, running north to south through the county. Here is the extensive outwash plains that separate the Marengo Ridge from the older glacial features to the east. And here's the area right in here that Glacial Park is forming right in the middle of this area right here. So here is same approach, looking at glacial landforms, looking at how they're put together, how wind and water moves through them, how fire moves over them, and seeing how that shapes the ecosystems that form in them. So what does this mean for you? I mean, yes, I've had 35 years of working with this, and you're saying to yourself, this is interesting and fun, but there's no way you can learn all this stuff. I mean, I've been at it for 35 years. I mean, you can't learn all that geology and soils and vegetation. So maybe it's just impossible. It was fun to go on a quick tour, but it doesn't really mean much for you. But I want you to back up and think about the theme. Physical geological landscapes influence the shape and function of ecosystems. Look at that sentence. The physical and geological landscape influences the shape and function of ecosystems. You know, when I started this 35 years ago, I had a hard time with it. I remember working a year and a half under my advisor, struggling to understand what he was talking about. I could see the trees. I was good at describing a soil. I could identify the rocks. I could identify the plants, but I couldn't understand these larger features, these ecosystems he was pointing to. I just couldn't figure out what he was talking about. And if you take this sentence, the physical and geological landscape influences the shape and function of ecosystems, you memorize that and you just say it to yourself every now and then as you walk through Glacial Park or some other natural area. Stop, look around you, look at the variety, and say that sentence. The physical and geological landscape influences the shape and function of ecosystems. Say it again. Walk to another place, say it again, and you'll start to see the associations. And as soon as you start to see the associations, they'll become real for you. And you don't have to just take this one little, hour and a half presentation and figure this is all you've got. Look back at the webinars on soil and geology and fire, those in particular, because they really deal at a more ecological level and at a landscape level of how ecosystems work. So you've got all three of those to provide a lot more detail of what I've talked about today. Certainly the webinars on trees and plants are also useful because, I mean, you'll now that you've watched the webinar today, you'll pick up when I'm talking about landscape features and soils and connections and fire influence that might have just whizzed past you when you first watched the webinars. Plants and animals are functioning parts of ecosystems. I can't tell you how much more completely I've been able to understand plants and trees today because I see them as functional parts of ecosystems. Isolated from that, they're interesting, you look at them, they're pretty, and I can identify them, but they don't become real, they don't become living things until you put them in the ecosystems and you watch how they grow and live and die. And in case you haven't noticed yet, if you've been with me in many of these webinars, maybe this is going over the top as a teacher, but what I've tried to do for 30 years when I've talked to students is try to make them broad and integrative thinkers. I know it's easier to learn to tell a white oak from a red oak. I know it's easier to learn to tell two kinds of goldenrod apart, and this is harder, and it stretches your mind a little farther, but it's worth it. When we understand land and its history, it becomes the basis for valuing things and places, and it's where we find the reason to conserve and restore. That's not a slogan. That's actually how I look at the world. I understand the land, its place, its history, how it functions, what it's made up of. That tells me how to value things and places. Why do I value some places more than others? Well, it goes back to what they're made of and their history. That's how I value them, not based on just putting an arbitrary value on the pieces and parts that make them up. I try to put them in that context and understand where they came from. And that's what gives us the reason to conserve and restore. Well, I'll leave it at that and entertain questions. Thank you.
Got a question in the chat. With all this research, does it answer any of your questions about the decline of white oaks?
Well, that's really focusing in there. It does it tell me about, I think most of the story I've told that I began to wheedle out of 10 years of studying oak reproduction, most of the issues with white oak reproduction have to do with dispersal establishment of acorns, the movement of fire. So in that sense, I suppose, yes, certainly the distribution of white oaks in the landscape is very intimately connected to glacial landscapes, and in particular parent materials, because white oaks simply don't occur on the gravelly soils of McHenry County. They seek out mostly the morainal areas where the soils are much finer textures. So in their geographical occurrence, where they have an opportunity to grow, is very much connected to what we talked about today. The story of their failure to reproduce mostly over the last century and a half is, I think, really focused in on events, post-European settlement events and land management that we imposed on that geological landscape.
We had a comment. Aldo Leopold has a great paragraph about which trees he values, which is very consistent with what you said on your last slide. Thanks, Tom.
Well, I think as an ecologist, I mean, when I talk about soils, people that have known me for years that think I'm a geologist because I talk about geology, and people that have known me for years that think I'm a soil scientist because I talk about soils a lot. And they're surprised to find out I'm not either, that I'm an ecologist. And for me, what it means to be an ecologist is that I'm partly a geologist, partly a soil scientist, partly a botanist, partly a zoologist, partly a climatologist. I have to be all those things in order to be an ecologist. And I think that's what I mean by broad and integrated thinking. All of us start in one place. I started with trees. I still love trees. They're still my friends. I still love to go out and sit in a grove of trees. It's very peaceful for me, but I understand the tree much more deeply, and I can connect it to the world around it and why oak trees dominated the McHenry County landscape for 13,000 years. Why is that? Well, part of understanding it is a part of understanding the landscape in which they occurred, and that's the kind of breadth and depth and integration I'm trying to get across in these presentations.
Got another question. How would you want to restore a reasonable natural landscape into the historically eroded soils from glacial buffs that deposited into a river floodplain, the hackberry silver maple area you mentioned at the beginning today?
It's a question of what would I want to restore that to its original meadow, or why would I?
How would you want to restore?
Well, that would be that's a very good question. That's a really challenging thing. I think in general, restoration is easiest on the top of the gravel hill, and it becomes harder as you walk down to the wetland because the wetland accumulates. The wetland, the water features accumulate all the influences of the European settlement and development around them. And so the Des Plaines River is flowing in the same channel, but it's not the same river it was 200 years ago. Neither is Nipperson Creek. It's a much flashier, more flood-prone river that carves much deeper grooves in the landscape. So it's a very different river. And so we can't really restore the Des Plaines River without restoring the entire landscape through which it flows. And so we can't really restore the bottomlands of the Des Plaines River without restoring the river. Does that mean that restorations are relevant? Well, no, because there's a Baroque Savannah there, not just on the higher terraces that be eminently subject to restoration. It doesn't even mean that we couldn't use an understanding of how rivers flowed through landscapes 200 years ago to restore certain aspects of them, such as we've done in Glacial Park with Nipperson Creek, 3 different episodes of restoration. We've done a lot of work on the stream. We haven't been able to turn the stream into a pre-European settlement stream. We can't do that. But we've been able to restore many of the features around the stream. We've been able to get many more native plants growing next to the stream. So we can always learn from restoration and learn from history, even though sometimes we're managing landscapes that we really can't realistically restore that riverside sedge meadow that would have been there 300 years ago. We can't do that now. Who knows, in 500 years, I believe in the future. In 500 years, maybe people will be in a position they can do that. Today, I don't think so. We can learn from the past and we can restore many features of the past, but in some cases, we're limited.
We're reminded of, I feel like in organic chemistry in college, the term structure affects function just pops up over and over and over again. That reminded me of what we were talking about today. And when we're restoring streams, a lot of the issues we see is that they're really steep cut banks, and that wouldn't really have happened. There's just so much more water flowing through now. So sometimes when we restore the streams, what we're doing is grading back the banks, so it's a less steep slope and have more of those natural communities. So in that way, we're trying to mimic the structure of what historically would have been there.
Yes, that's very true. The only thing I would add now is this doesn't. I mean, sometimes you listen to teachers and you think, yeah, that's what the guy's saying. Yeah, that's what he's saying. But actually, when I walk through Glacial Park, what I see are ecosystems. Now, yes, I can see trees and plants, but that viewpoint, which is why I kept telling you, geological form of landscapes influences the shape and function of ecosystems. If you just say that to yourself and keep doing it, it becomes a reality. And that's what I see when I look at the world today. And it's just so enriched my understanding of the world that I try to teach to people. I know it's harder than, it's not easy to learn how to tell a white oak from a bur oak, but it's easier conceptually. You can see a tree, and conceptually it's hard for people to see ecosystems, but you can do it. I figured out, I don't know that I ever really tried, it just happened. It happened by working with it, by having to work with it for several years in a northern forest landscape. It just became a reflex as I walk through the world today. So I want you to maybe have that same experience I did.
Hey, Tom.
Cool. Go ahead, Joe.
Yeah, I'm having trouble with my technology here. But I'd like to ask you, you said that plants and animals are functioning parts of the ecosystem. Are human beings animals? Are we a functioning part? Or are we a malignant tumor?
I think certainly human beings, so it's a complicated question, but we are animals, therefore we are functioning parts of ecosystems today, and that's important to understanding why we need to do restoration today if we want to hold on to anything that was here before. Because human beings and the world they have constructed around Glacial Park are constantly influencing Glacial Park and all of our natural areas today. In order to hold on to anything that was here in the past, we will have to work at it. So in that sense, understanding human beings as functioning parts of ecosystems is essential to the argument for ecological restoration. We've also had a lot of damaging effects. I'm not sure, I don't like to use words like, or terms like malignant tumor, but we've certainly had lots of damaging effects. I mean, understanding human influence is a part of understanding the argument for ecological restoration. To me, understanding this landscape approach of putting each natural area in a context, which is in all cases a human context today, it ought to jump out at you just looking at that, looking at an aerial photograph of Glacial Park sitting in a developed landscape ought to tell you that there's no way you can ever fully restore Glacial Park and have it sail on into the future on its own without doing restoration, because it's constantly going to be influenced by the human world around it. So we need to recognize that, we need to take responsibility, and that's what I think ecological restoration is about. It's about fighting those malignant influences, and by repairing on an ongoing basis, we're never going to be able to stop. It's a relationship, not an action that you ever complete.
I think it's important to note too that humans have been part of the landscape for tens of thousands of years as well. So, just because European settlement was more recent doesn't mean there weren't Native American influences on the landscape before that. We know that Native Americans had been purposefully doing fire on the landscape as a way to keep the prairies as a grazing pasture for bison, for example. So we have always been intimately involved with the landscape, just a matter of how we're perceiving that. So I think it's unrealistic to assume that there's really any truly wild areas. Either there's a historical piece of Native American history there, or moving forward, humans are here, we're going to be here, and we're going to be influencing the landscape as we go.
It's an excellent point, Jackie. And if you want a lot of background on that, just watch the webinar on fire, where I talked a lot about indigenous human influences through fire on landscapes, not just here, all over the world. So yes, very important point. Our present relationship with the world around us doesn't define the human relationship, but only one particular human relationship.
I had another scenario question in the chat. If we had money to buy 1,000 acres, should it be one large site or 20 to 30 small sites at the tops of the moraine, headwater niches, ephemeral wetlands, etc.?
Oh, that goes back to that's been a question in preserve design and really started being asked mostly in the 1980s as part of island biogeography theory, and the one big or many small question. I don't know that anyone's completely answered, and I think conservation tends to find it hard to walk away from a place like Bystreaky Prairie. That is one of the few remnants of mesic wet prairie left. It's hard to walk away from because it's small, and to buy 1,000 acres of cornfield, and yet the hope for the future is in building larger natural areas like Glacial Park, which is now 3,600 acres. Pleasant Valley is grown to enormous size. This gives hope for restoration in the future. So I think it has to be a balance between the two. I know that's probably not, you wanted a commitment one way or the other. I think maybe that's a choice where we have to split the difference and save the best the best of what's left, but also to look to a future in which we hopefully can encase the best of what's left in a larger restored landscape. Maybe just try to honor those little places as best we can. If we can't by their surroundings, try to hold on them as long as we can, and to build larger natural areas where we can get the plants and animals in Illinois to live together again, as they did for 11,000 years since the climate warming, and we're doing just fine until Europeans got here. So I think it has to be a balance between the two, but I understand it's an important question, and one we have to wrestle with really every day as conservationists.
Had a comment, perhaps it's time for a Tom Walks and Talks series, followed by, yes, it's a good suggestion.
Tom Walks and Talks.
Uh-huh.
So
We always
you
take
also-
suggestions.
okay, I wanted to say that this is not a virtual background. That's actually a real chalkboard, okay? I'm not completely extinct now. You know, the chalkboard, I just looked it up. Chalkboard was invented in 1801 in Scotland. Revolution in teaching. I'm still a believer in chalkboards, so yeah. And they have to be smudgy. If you clean them, you never want to put another mark on them. And chalkboards have to invite the next mark. So a smudgy chalkboard is the best educational technique.
Any other questions out there? I've read all the questions in the chat. You're welcome to type them in or to unmute and ask. We had scheduled until 12 p.m. so we've got a little bit more time if anyone has questions, but we can always end whenever there are no more. Well, I'll give a minute just to, if anyone has other questions, to type them into the chat, but to share the upcoming dates for our next couple of Tom Talks. We have on March 3rd, What Ecology Tells Us About the Living World. And on Thursday, March 31st, The Man Who Broke Nature, Charles Darwin and the Origin of Species. So you can sign up for those at any time. You can email me if you're having issues at the website. Appreciate everyone dealing with the new way of signing up for this. We're just trying to make things a little bit more streamlined with our database information. We had a question, could you do a talk on cold and cool water streams?
Do a talk on
Cold and cool water streams.
well, a lot of that. I was talking about a lot of the influences of that today. I mean, it's really groundwater, and all of that has to do with geologic forms, topography, water movement through them. We'll no better off on what we can do in Tom Talks in the future. I really want to invite you to the next two. It should be exciting. I'm really looking forward to them. The next one is going to be kind of amazing things about ecology you never imagined. And the second one on Darwin is ever since I first read the book in the middle 1980s, I've been a student of Darwin. I've read it many times. It's just become a part of my life. And I just thought, Jackie asked me what I wanted to do, and there was a pause, and I just said, oh, I want to talk about Charles Darwin. And I think it will be interesting to do because he reshaped the way we think about the living world. And I'm going to take a special section toward the end of that to talk about what it means to us as conservationists and restorationists today, both of which activities really developed after Darwin wrote the book. But I think it has some very important messages for us today. So that will be, that's what's coming up, and I hope to see you then.
All right. I don't think there's any other questions in the chat. So I think that's all we got for you today. We really appreciate you joining, and hope to see you at an upcoming roaming restoration day, one of our Tom Talks, or just around. So everybody stay safe, stay warm, have a wonderful day.
All right, thank you. Goodbye.